All right. Um, we're going to take a look at this problem right here. On your review, it asks you, hey, is this a function? Okay. So, well, how can we tell if this is a function? Well, we can see it passes the vertical line test. So there's no times where you're going to have two different inputs with the same, or you're going to have the same input with two different outputs. So since it passes the vertical line test, yes, it's a function. It only hits once each time. Okay, so then it asks, what does it ask next? It asks for the domain and the range. So the domain, what can we plug in here? What can we square? Well, we can square anything we want. So the domain is all real numbers. The range, the lowest we can go is 2. Actually, we can equal 2, so that's inclusive there, to infinity. All right. Next problem asks, is this, it says, can we find an inverse to this? If so, what's the inverse? I can tell you, just staring at it, this thing is not invertible. Some operations that are not fully invertible are any of your even functions like x squared or absolute value of x. We know that those aren't going to be invertible because they fail that horizontal line test, okay? Basically, for any given input, or sometimes there's multiple outputs that are the same. So I have two different inputs that give the same output. So when I switch it, that's two different inputs that give let's try that again. All right, so we're going to see if we can invert this. So without a lot of fanfare, we can't. We can't invert this. Some functions that you can invert, x squared, absolute value of x, any of these even functions fail this horizontal line test. They have repeated outputs, which if you invert them, become repeated inputs, where you've got the same input giving you different outputs, and that's no good for a function. So since these fail, I'm looking at this, it's got an x squared in it, we're not going to be able to invert this. All right, you've got a piecewise function here. So we've got two different rules. So if x is less than or equal to -3, we follow this rule. If x is greater than 3, than -3, we follow this rule. So first it asks us, hey, what does this look like over the interval -∞ to -3? Well, this matches up with this. So what they're wanting to see is, oh, it's going to look something like this, okay? Because that's how we would graph this. -12, slope of -4, okay, over this specified interval, okay? Then it's going to ask, hey, what does it look like? Sorry, I can't really see that. Next, it's saying, hey, what does it look like over the interval -3 to infinity? Oh, sorry, I forgot. This is or equal to. So this, the general shape, it's going to be some sort of parabola. Okay, shrunk down a little bit. Okay, compressed. So when it comes time to draw the actual piecewise function, we say, I'm going to use this over this interval. So we keep going until we hit -3, and then we get rid of that. And then here, infinity, all the way down to -3, we're going to use that. And at -3, we use this guy. So that's going to be what a piecewise function looks like. All right. This question asks you to combine two functions. So we've got f of x equals x minus 10 over -3, and g of x is x plus 9. All right? So it asks us to find f plus g of -3, f minus g of -3, f times g of -3, and f divided by g of -3. And this seems super redundant, but let's just shove it in here, see what happens. So if I plug in -3 to my f function, I get -3 minus 10 over -3, so -13 over 3. If I plug in -3 here, I get 6. So it's -13 over 3 plus 6. So this is 5 over 3. Okay, I just changed this to 18 over 3, so we have a common denominator. Now subtracting them. Same concept. So what is that? -22 over 3. Now we're multiplying them. So if we do this, we can cross cancel here. This is 2, this is 1. So this will be what? -26. And then finally we divide them. Okay. Whenever you're dividing, if you want, you can multiply by the reciprocal here. So, and there you go. So that's all 4 of those. All right. So the next problem is giving us this function right here. And it's asking us, hey, are we reflecting? Are we stretching? Are we left? Are we right? We're trying to figure out all of these things. The good news is it will graph it automatically for you. You just have to describe the transformations. So what does this negative do? That's a reflection over the x-axis. What does this 2 do? Okay, that's a vertical stretch with a factor of 2. This plus 3 moves us left 3. This plus 5 moves us up 5. Okay, now it wants our domain and our range. Now, normally, for our parent function, our domain would be only positive numbers and 0. So normally, our domain would be 0 to infinity. But let's look at what winds up happening here. We're moving all of our x's left 3. So that means now it's -3 to infinity. Okay, and we can test that out. When I put -3 in here, I get 0. So that's the lowest that I can go without getting an imaginary solution there. Normally our range, okay, so this was our domain. Normally our range would be 0 to infinity, but let's look at what's happening to our y's. So we reflect over the x-axis first. So that's going to change these signs. Okay, and then we're going to move up 5. So this becomes 5. Okay, you could also look at a graph, and that would also give you the information that you want. All right, let's take a look at another piecewise function. Okay, f of x equals 3/4 x plus 1. If x is less than -6, or this nice little quadratic here, if x is greater than or equal to -6. Now, my problem, the first thing it asks is to evaluate this function at x equals -5. Well, let's check this out. Is that less than -6? No, it's not. Is it greater than -6? Yes, it is. So I plug this in here. -5 squared minus -5 minus 6. So 25 plus 5 minus 6. So 30 minus 6 is 24. Okay, so that's our value there. Next, it asks for the value of our function at x equals -6. So is it less than -6? No. Is it greater than or equal to -6? Yes, it's equal to. So we're going to use this guy again. So -6 squared minus -6 minus 6. So 36 plus 6 minus 6. Those cancel, and we get 36. Last thing it asks us for is, what if x is -10? Well, is -10 less than -6? Yes, so we are going to use this guy this time. So 3/4 times -10 plus 1. Okay, so times -10 over 1. Cross cancel here. So we get 15, -15 over 2. Plus 1. This is 2 over 2. And we get -13 over 2. All right. So again, we just look at our instructions, and that tells us which one to use. All right. So all right, it wants us to go ahead and solve this one. So how do we undo a fourth root? Well, we take it to the fourth power. So fourth power on this side, fourth power on this side. 2 times 2 times 2 times 2. That is 16. That cube root just falls off. 4z equals 15 divided by 4. Z equals 15 over 4. Get a better marker. All right, we've got another quadratic here. So now we could square this out and then try to do quadratic formula, all that fun stuff. Nah, this one's already squared, so we're just going to do square root on both sides. But remember, if I square root both sides, I have to acknowledge this could be positive or negative. So then I add 6 to both sides. So 6 plus 4 winds up being 10. 6 minus 4 winds up being 2. So my x could be 10 or 2. All right. Let's take a look at this guy right here. It wants us to graph this guy. So if I graph this guy, I want to know a lot of things. First thing I want to know is the vertex. Now, to get the vertex, my x is going to be what I like to call the mini quadratic formula, negative b over 2a. So negative b over 2a, so negative 2. So the x of my vertex is negative 2. Well, how do I find my y? I just plug it in. So negative 4 plus 3 is negative 1. Next thing it asks us for is x-intercepts. Now, if it intercepts the x-axis, that means the y is 0. Okay, so I set y equals to 0, and I solve for x. Now, this is a nice one because I think this factors here. 3 times 1 adds up to 4. So I wind up getting negative 3, 0, and negative 1, 0 are my x-intercepts. Okay. Then it asks us to find any other points other than the ones that we've already found. Well, we've played this game before. You just shove in a number. So I'm going to start easy. I'm going to plug in 0. So 0 plus 0 plus 3. So my other point now is 0, 3. Plug in 1. 1 squared, 4 times 1 is 4, plus 3 is 8. So 1, 8. And the last thing it's going to ask you to do is graph. All you have to do is use those points that you already used, and you're good to go. All right. So here it wants us to find the slope and the y-intercept. I'm going to rewrite this. So remember, this is slope-intercept form. So I'm just going to move these around using the commutative property. Oops, there we go. So now that makes it pretty obvious. My m is negative 7 over 6, and my b is 7. So my slope is negative 7 over 6, and my y-intercept is, sorry, that's wrong, 0, 7. Okay, then it asks you to go ahead and graph this real quick. So plot 2 points. So we start with an easy point, 0, 7. And then we could do lots of things here. Down 7 over 1, 2, 3, 4, 5, 6. Using our rise over run. So down 7 over 6. And boom, we've graphed it. Move this over a little bit. A little cleaner spot on board. So let's see. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. My beautiful circle here. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so this is, I believe, negative 5, 0, negative 5, 4, negative 5, 8. This is negative 1, 4, and this is negative 9, 4. Okay, so it's asking us if this graph is a function. Well, we can see that visually with vertical line tests. It's hitting multiple times. Okay, so answer here is no, it is not a function. All right, I believe the next thing it's going to ask is to prove it. No. 1 second. No, it's asking us for domain and range. Okay, so our domain is all of our possible x's. Well, how far to the left can we go? Well, we can go to negative 9, and we actually hit negative 9, so we need braces there. How far can we go to the right? Negative 1. And our range, we go from 0 to 8. So that's our domain and range. All right. All right, we're going to solve this quadratic real quick. Again, it says to solve it using quadratic formula on here, but there's no way I would do that. I see a common factor here, 2y. So I get 3y minus 1. So that means both of these factors could possibly equal 0. So 2y equals 0. 3y minus 1 equals 0. So we get y can equal 0 or y can equal 1/3. All right. It wants us to find the domain of this guy. So our domain normally would be 0 to infinity in these guys. But what are we doing? We're having to shift it left 3. So that's going to give us this guy. Again, -3 plus 3, that's 0. That's the lowest we can go. If I go any lower than that, we're in trouble. Okay. So it wants to get f of x minus 1. Well, f of x minus 1 just means we're shoving x minus 1 in for this guy. So it's x minus 6 in that square root. And that's it.